Hi everyone, and welcome to this SkillPill. My name is Raresh Mihalake, and I'm a data engineer at BT Provider. Today, we'll discuss context variables in Talend, focusing on how to define and use them effectively. Together, we'll explore a practical example and see how context variables can be defined and applied in a job to solve a specific task. Without further ado, let's get started. First, let's establish the difference between a context and a context variable. A context in Talend allows jobs to adapt to different environments such as development, UAT, pre-prod, prod, and can be job specific or shared across multiple jobs. A context variable is a user-defined variable tied to a context and can be set as either repository or built-in. Now, let's turn our attention to the example. Imagine you are part of the data engineering team working on a project for a large retail client with supermarkets across Romania. Each day, these supermarkets generate product sales data stored in Excel files. Your task is to build an ETL process that transfers daily data from Excel to the client's database using context variables to configure components and manage logging. Two MySQL tables have been created for this task. Shop1 table, which mirrors the structure of the Excel file and stores product details like product name, product ID, price, state, and the job log table, which tracks daily ETL details including the job start and end times, execution duration, status, and number of records exported. Also, two context groups have been defined, one for connecting to the MySQL database and another for logging. Let's take a look at these context groups. In the repository, navigate to Contexts and expand the list. Right-click on each context group and select Edit Context Group. In the DB Connection context group, we can see context variables created for the database credentials, including host, port, database, username, and password, along with the respective data types and values. In this example, we are using the def context. Next, let's go to the logging context group. In the logging context group, the context variables correspond to the column names in the job log table. Default values were added to avoid potential string warnings that Talend might raise during job execution. However, these values will be overwritten by the actual ones at runtime. To add these context variables to the job, simply drag and drop them into the context view with the job open. In general, to create a context group, right-click on Context and select Create Context Group. Enter a name and optionally a purpose and description. Then, click Next. In the second window, you can add context by clicking the plus icon on the right. Here, you can edit an existing context by selecting it and clicking Edit, or add additional context as needed by selecting New. Context variables, along with their data types and values, can be added by clicking the plus icon at the bottom. The advantage of creating context groups using the repository method is that context variables can be reused across multiple jobs. Next, we need to create a context variable to capture the file path using the built-in approach. In this case, the file path context variable was defined. The process is similar to what was described earlier, but in this case, the job must be open and you need to navigate to the context view. It is important to mention that built-in approach makes the context variables available only within the job where they were created. Let's now move on to the components. First, we have the tPreJob component, which is useful for setting up configurations that the main job relies on. Next, we added the tJava component, and it's important to understand how to initialize a context variable inside the tJava component. This is done using the syntax context.variablename equals the value to be assigned, ensuring that each line ends with a semicolon. Here are the variables we've set. Job start date, and we can see that Talend's built-in functions were used to calculate it. The job name, which stores the name of the job as a string, the purpose, and this variable specifies the purpose of creating the ETL, and the schema name. In this case, it is set to training, which is the schema that contains the shop1 table. Next, we have the TDB connection component. This component establishes a connection to the MySQL database. The configuration steps are the following. From the database drop-down menu, select MySQL and verify that the DB version is the correct one. We remove the double quotes and added the context variables for the database credentials in the appropriate fields. These variables can be entered either manually or by using the auto-completion feature with Ctrl plus space on the keyboard. Go to the Advanced Settings tab and enable the auto-commit option. This will ensure that data is automatically committed to the database when the job finishes. Next, we have the tfile input XL component. This component is used to read the daily data for a specific supermarket. Navigate to the Basic Settings tab, and depending on the format of the XL file, you may need to enable this option. Next to the file name /stream, add the built-in context variable, in this case context.filepath. In the sheet list field, click on the plus sign and enter the name of the sheet you are reading data from, enclosed in double quotes. If the Excel file contains column headers, make sure to enter one in the header section. Also, click on the three dots to the right of Edit Schema and add the column names along with the respective data types. Next, we have the TDB output component. This component is used to transfer data from the Excel file to the database table name shop1. Make sure to use the existing database connection and in the table field, enclose the table name in double quotes. Set action on table to the default setting and action on data to insert. Also, ensure that the schema is synchronized with the input. Next, we have the logging logic. We have two main branches. If the data transfer is successful or if the data transfer is not successful. If the data transfer is successful, we add a tjava component and we link this component to the tfile input XL1 using an onSubJobOK trigger. This instructs Talend to follow this branch if the data transfer completes successfully. We also define the following context variables: job end date, and this one is constructed similarly to job start date, job duration, and in this case Talend's built-in functions were used to express the duration in seconds. Row count exported. The system variable of the output component is used here to retrieve the total number of records that have been transferred. And the job status. Since we are on the success branch, we hardcode the status as success just before inserting it into the log table. Next, we have the TDB row component, and make sure to enable the use an existing connection option. In the query section, include the insert statement, and you can see that in the value section, we've included the context variables we just defined. Next, add the TTP close connection component. This way, we ensure that the connection is closed at the end of the flow and the data is committed. Next, if the data transfer is not successful, this branch is configured similarly to the successful one with the following differences. First, we link the tjava component to the tfile input XL1 using an onSubJobError trigger. This instructs Talend to follow this branch if an error occurs during data transfer. Also, we set the job status to failure. The configurations in the other components remain the same. Now, the final step is to run the job. Normally, we can choose the context at runtime from the drop-down menu on the right, and the context variables will adjust based on the selected context. In this case, we have only one context, dev, so let's run the job. Okay, so the job started. As we can see, the job runs smoothly, showing the start and end dates as well as the number of records inserted. We can now check MySQL to see how the data is populated. So let's go to MySQL. Here, if we do a select star from shop1, we can see the values for each product, and also a count reveals that 10,000 records were inserted. Additionally, if we query the job log table, we can see that the performance metrics were included as well. And that's it. I hope you enjoyed this session, and if you have additional questions, please let us know in the comments section. Thank you for watching.